Hi everybody. In this video, I'd like to give you some notes about how to solve quadratic equations, especially in the context of physics. First of all, in math class, you've probably seen quadratic equations of the form ax squared plus bx plus c, and they are parabolas. And so for example, if we had the equation 2x squared minus 4x plus 1, you would be able to figure out where that thing crosses the x-axis using the quadratic formula. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a is 2, b is 4, and c is 1. So you would dutifully take, b is negative 4. Already, danger looms. Okay, so it's negative 4. I'd plug in negative 4 for b plus or minus the square root of negative 4 squared minus 4 times 2 times 1, that's a and c, all over 2 times 2. Now, you may be saying to yourself, this is pretty tedious. And it is pretty tedious. And we have technology that allows us to do this faster. And in physics class, that's what we're going to do. We're going to use technology. So instead of actually solving the problem, I'm going to move on to a solver. This is at mathisfun.com, and I'll post the link in this section. And so what I would do to solve this is I would put in 2 for A, negative 4 for B, and 1 for C. Okay, and now this is really nice. It graphs the parabola for me down below, and then it shows me where it crosses the x-axis, and those are my two solutions. So these roots are my solutions. They're the values of x. So x equals 1.707, or x can equal 0.293. Okay, there's two possibilities there. So let's take a look then at a situation in physics where we would actually use this. So let's say I launch a ball at an angle of 45 degrees with a speed of 10 meters per second. When does it reach a height of 2 meters? So let's sketch this. So here's the ball. I'm launching it at 10 meters per second, 45 degrees. And in a different color, I'll kind of sketch a path for the ball. There's the path for the ball. Now, if the ball goes that high, it's going to hit 2 meters twice on the way up and on the way down. So let's identify our variables here. We've got that delta y is positive 2 meters. We've got that the initial velocity is 10 meters per second. We've got theta, or our angle, is 45 degrees. We know that our acceleration is g, or negative 9.81 meters per second squared. And we want to know when. We want to know time. Now, there's really just one equation that we're asking you to use for vertical motion of a projectile, and here it is. And I'm going to plug in the values that I know. So delta y is 2, vi is 10, sine 45, t, plus 1/2 times negative 9.81 times t squared. 10 times the sine of 45 is 7.07. I would plug that into a calculator. 1/2 times negative 9.81 is negative 4.905 t squared. And then I'm going to subtract 2 from both sides so that I have 0 equals negative. Oh, that's a mess. Hang on a second. I'll do this in a minute. I'll do this in the next step so it's not such a mess. Okay, so I would subtract 2 from both sides so that I have 0 equals negative 2 plus 7.07 t plus negative 4.905 t squared. And this is in the form of a quadratic equation. It's backwards. C is first, B is in the middle, and A is last. So let's go back over to my handy little solver here. A would be negative 4.905. Ooh, how about numbers? B would be 7.07. And C would be negative 2. All right, so I've got 2 roots here, 1.05 and 0.38. And let's look at this picture. Okay, the roots again are where the parabola crosses the x-axis. But in this problem, what the roots mean is when the ball gets to 2 meters above my hand. So it gets to 2 meters above my hands first at 0.386 seconds. And then the second time at 1.055 seconds. So we're really looking at when the ball gets to here and then to here. My handwriting's a little messy. So T is equal to 0.386 and or 1.055. Sometimes you'll get an answer that doesn't make sense. What if you get a negative value for T? We cannot go back in time, so you're going to ignore it if you get a negative value for T. What if you get a complex? Some of you may have studied I, which is the square root of negative 1. If you get a complex value, it means there's no solution. It means the situation is impossible. But in this class, we'll try to give you situations that are possible because it's physics and we are studying the physical world. Okay, hope that makes